So we're going to keep that in mind, and then now still do one example, let's say from Gen Chem, to really reinforce the idea of Lewis structures. So here are the rules from Gen Chem. Once again, we're not going to spend a lot of time on Gen Chem molecules because we're in organic chem and we have enough to cover. So the rules is that you always add up the number of valence electrons from all atoms. So in this case, carbon, when we have 3 oxygens, you list them. I like to list them like that. And then the charge, we're going to get to it in a second. So as we talked about before, we need to look up or remember how many valence electrons does carbon have. So if we go here, we see that carbon has 4 valence electrons and oxygen has 6. And we have 3 of them, remember. Now here it says, for every negative charge, add an electron to the total number of valence electrons. For every positive, subtract an electron. What we have here is we have a negative charge. We have a -2. So that means I have to add 2 electrons. All of this would come out to be 24 valence electrons. So this is your total, the total number of electrons, and you have to use all, okay? Must use all. No more, no less. So we go to the next one and says the next rule says connect central atom to outer atoms via single bonds. So we have CO3 minus 2. Generally, the least electronegative atom, carbon, we're going to get to electronegativity in a second, but or what's written first is your central atom. So in this case, we have C, and we're going to connect the C to the 3 oxygen via single bonds. So if you notice here, these are all single bonds. Now, what you need to do is you need to complete the octets of outer atoms first and place any leftover electrons on the central atom. So here we have a carbon, and I'm going to count so you can, if you recall. So far, this oxygen has 2 valence electrons. These, remember, this means 2 electrons. So this double counts as we just saw in the analogy before. So in this case, this oxygen has 2, so it needs 6 more. The octet is 8. Well, we have in the inventory about 24, so we go on and actually place lone pairs around. Same thing. And now the oxygen, each oxygen is happy. It has 8, 2, 4, 6, and this, remember, double counts, 8. This one has 8, and that one has 8. Do we have any leftover? Well, let's count. If we have 8 electrons here, we have 8, and we have 8, that comes out to be 24. So we actually have 0 valence electrons left. So no leftover electrons, no leftover. So let's go on to number 4. Number 4 says, if there aren't enough electrons to give the central atom an octet, try multiple bonds. So we're going to bring this down. Now, this is what I'm showing you is the traditional method that we use in Gen Chem. So I'm using it here again for basic molecules, and we're not going to dwell on this for a very long time. So if you look here, it says use one or more of the unshared pairs of electrons on the atoms bonded to the central atom to form double or triple bonds. So what we could do is we could take one of these lone pairs. I chose this one. Could be from that one or that one, and that's another concept called resonance. And you bring this to form a double bond. So if you notice now, why did we do that? You might say, why didn't we stop before? And the reason why we didn't stop here is because carbon has 6 valence electrons, 3 bonds. 3 bonds is 6. So once again, we had to go and use a lone pair from, let's say, this oxygen to form a double bond. So now if you count, this carbon is happy, has 2, 4, 6, 8, and that oxygen is also happy. So in this case, you are done. And again, that's the exercise of drawing a simple Lewis structure for an inorganic molecule. So in this case, we had to put this in -2 because remember the formula started with, it was CO3 minus 2. So let's practice this one. C has 4 valence electron. We have 2 H's, and we have an O. 1 valence for hydrogen, 1 valence for hydrogen, and 6 valence for oxygen. Now, there are no charges on here, so I don't have to add any extra or subtract. So if I add up all of those electrons, I get 12. Now, C is your central atom. Look, we're going to talk about organic chemistry in this class. So, and it's all the time you will see carbon is your central atom unless it is a molecule that has no carbon in it, like water, ammonia, etc. So, if you look at this point, here's how we attach them. C has the 2 H's attached and the O. Now the oxygen is in happy, so we have to put the electrons on the outer atom first. Now let's ask ask ourselves how many electrons have we used? We have 2, 4, 6, 8, 10, 12. Okay, so we used all. We have no leftover. So what do we have to do if we have no leftover electrons? So we have to do a multiple bond or a double bond. So in this case, and once again, you should know why I had to do this is because carbon had 6 valence electrons. So the key is to have 8, or as you just read before, you have to have 4 bonds on carbon. So here's your molecule, and that is formaldehyde.